talk about complements of a set, let's talk about the universal set. Universal set. Universal set. Universal set is the set contain all the sets in the consideration. It contain every other set in the whole discussion. Like a set, talk about set of students in basic science. In faculty of science, we have biology, physics, chemistry, mathematics. So you can see that universal set is a set that contain every other set in the whole discussion or in a particular discussion. So when you're talking about universal set, for example, a set of alphabets from A to Z, A, B, C, D, E to Z. And we have set V, set of a vowel, contain the set of a vowel A, E, O, I, U. And we have set C, the set of the consonant B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, U, V. V is not there. V, W, X, Y, and Z. C complement. All the elements in universal set that is not in C, which is I, E, O, U, I. That's C complement. So when you say the complement of a set, A, that's A complement, is says such S such that S is the element of universal set and S is not an element of A. It's called the complement of A. Union of a set. Let A and B be two arbitrary sets. A union B is the element in A and B. A union B such that S is equals to A such that S is the element of A or S is the element of B. 1, 2, 3, 4. B equals to A, B, C, D. So A union B equals to 1, 2, 3, 4, A, B, C, D. Intersection. Let A and B be two arbitrary sets. A intersection B equals to X such that X is the element of A and S is the element of B. That is, element that is common to both A and B. Element that is common to both A and B. A, 1, 2, 3. B, 3, 4, 5. A intersection B equals to 3. That is element that is common to both A and B. This is set A and this is set B. The element that is common to both of them. A union B equals to B union A. Commutativity. To prove that union of a set is commutative, let's prove that A union B is equals to B union A. Then we said if let X be the element of A union B, that implies that X is the element of A or X is the element of B. If X is the element of A or B, then X is the element of B or X is the element of A. That implies that X is the element of B union A. Therefore, A union B union C equals to A union B union C. Associative property to show that A union B union C is equals to A union B union C. Let X be the element of A union B union C. That implies that X is the element of A union B or X is the element of C. If X is the element of A union B or X is the element of C, that implies that A is the element of X or X is the element of B or X is the element of C. This implies that X is the element of A or X is the element of B union C. This implies that X is the element of A union B union C. Therefore, A union B union C is equals to A union B, A union B union C. With the proof, we have been able to see that the union of a set is commutative and at the same time is associative. Intersection. A intersection B is equals to B intersection A. That is the commutative property. Commutativity property is owned by intersection of two sets. To prove, let X be the element of A intersection B. That implies that S is the element of A and S is the element of B. If S is the element of A and S is the element of B, that implies that X is the element of B and X is the element of A. Therefore, X is the element of B intersection A. So A intersection B is equals to B intersection A. Proving it the other way around, you can say B intersection A is equals to A intersection B. That implies that if X is the element of B intersection A, that implies that S is the element of B and S is the element of A. That implies that S is the element of B intersection A. Therefore, B intersection A is equals to A intersection B. So B A intersection B is a subset of is equals to B intersection A. Some basic idioms in algebra of sets. When you talk about idioms, you are talking about some basic truths which has been proved to be true and correct. Number one is commutative idioms. Commutative with respect to union of a set. A union B is equals to B union A. Some of these idioms have been proved before in our previous class, and you can as well go ahead and prove the rest. Commutative with respect to intersection. A intersection B is equals to B intersection A. The associative axioms. Associativity with respect to union. A union B union C in brackets equals to A union B in brackets union C. Associativity with respect to intersection. A intersection B intersection C in brackets is equals to A intersection B in brackets intersection C. Distributive axioms. Union is distributive over intersection of a set. Intersection of a set. A union B intersection C in brackets is equals to A union B in brackets intersection A union C. Intersection is distributive over union of a set. A intersection B union C in brackets is equals to A intersection B in brackets union A intersection C in brackets. Idempotent axioms. A union A is equals to A. A intersection A is equals to A. Axioms of absorption. Let A and B be two arbitrary sets such that A is a subset of B, then A union A intersection B in brackets is equals to A. A intersection A union B in brackets is equals to A. Axioms of complementation. A union A complement is equals to union of a set. A intersection A complement is equals to empty set. Axioms of double complementation. Complement of set A is equals to A. De Morgan's rule. A union B complement is equals to A complement intersection B complement. A intersection B complement is equals to A complement union B complement. Prove this as homework. Show the proof of this assignment. We make use of these axioms in simplifying expression in sets as we do in algebra when you want to simplify expression in algebra. For example, show that A union A complement intersection B in brackets equals to A union B. Solution. A union A intersection A union A complement intersection B in brackets. Using a distributive law, we say A union A complement intersection A union B complement. Don't forget our union is distributive over intersection of a set. So A union A complement is a universal set. Intersection A union B universal set intersection A union B, that is element that is here intersecting elements in the universal set, which is A union B, which is the same thing. Therefore, A union A complement intersection B is equals to A union B. This is the assignment. You have to simplify this. Simplify the following expression.